Hi, this is Dr. Simon Romero and I'm here to present you the video tutorial for tangent planes to level surfaces. So the idea is, first we're going to prove that the gradient vector is going to be orthogonal to level surfaces. So suppose that we have a level surface of a function of three variables, and then suppose that we parameterize a curve inside of the level surface. The thing that we're going to have here is, since this curve now is in 3 dimensions, we're going to have 3 components. We're going to see how the derivative of the vector function is actually going to be a tangent vector. And this tangent vector is going to be tangent to the level surface, and we're going to see how the gradient vector interacts with this tangent vector. And notice that this is an arbitrary tangent vector, so it's going to be the same for any tangent vector that you have on the surface. So a level surface is described as all the values on a function of 3 variables that they are equal to a constant. So since we have a curve, we're going to put all x, y, and z as a function of a parameter t. Then the thing that we're going to take is we're going to take the derivative with respect to t, and if you see, we apply the chain rule in this side and it's 0 in the other side because the derivative of a constant is 0. Once we have that, if we separate into components, we separate the components. In one side we have the gradient vector, and we have the dot product of the gradient vector and the derivative of r. So the thing that we're saying here is that tangent vector is going to be orthogonal to the gradient, but that tangent vector was an arbitrary tangent vector, so at the end we're going to say that the gradient vector is going to be orthogonal to all the level surfaces of a function of 3 variables, just like we saw in functions of 2 variables. But that gives us a consequence that since the gradient vector is orthogonal to all the vectors that are tangent, the gradient vector is going to be the normal vector to the tangent plane at the point ABC. And for that, we're going to obtain a formula for the equation of the tangent plane. So if you have the tangent plane of a level surface f of x, y, z equal to k at the point ABC is described by this equation. Formally, what we're saying is, if you have an equation with 3 variables, we can compute the tangent plane by just doing that. Notice that this is the gradient vector. Let me give you an example. So notice that here we have a formula that has x, y, and z equal to a constant, and we're going to try to find the tangent plane at this point. So we start computing the gradient vector, that gives you equal to that. Then we evaluate the gradient vector at the point that we want to compute the tangent plane, that gives you equal to that. So the equation of the tangent plane to the surface at that point is going to be just, these are going to be the coefficients, or you put them in the place of the normal vector, and the point is going to go inside of the parentheses and equal to 0, of course. And this gives you an equation of the tangent plane. Thank you.